Okay, so Assalamualaikum warahmatullahi wabarakatuh. And again, good morning, good afternoon, good evening, good night. Okay, so let us start with the third set. Okay, so this is part A. Alright, so question number 1, given that fx is equal to x squared minus 9 over x squared plus 2x minus 15 for x not equal to 3, and then c when x is equal to 3, and then so now find the value of c if f is continuous for all x. Okay, so we do know they are continuous. Okay, so let me firstly write down the first condition. So f of 3, so this is equal to c. So the second condition, I need to calculate the limit. So the limit for x approaches 3, so we're going to substitute into x squared minus 9 over x squared plus 2x minus 15. Okay, so if you do try to substitute x with a 3, what you are going to get is 3 squared minus 9, which is simply equal to 0. And then 3 squared, so 9, 9 plus 6 is 15, 15 minus 15, so that is also 0. So we do see 0 over 0, so that means we can choose one of these two, so we can either factorize or times with the conjugate. But obviously I don't have anything with a set, so I'm gonna factorize then. Okay, so let us factorize our denominator. Okay, so we have x, 5, 3, so this is 5x, 3x, so we want to get positive 2, so positive 5, negative 3, we are going to get positive then. And then I'm gonna factorize my numerator as well, so that is a squared minus b squared, so a plus b, a minus b. Okay, so this is equal to the limit of x approaches 3, so our numerator will be x plus 3, x minus 3 over x plus 5, x minus 3. And then of course you cancel out x minus 3 and x minus 3, so we are left with the limit for x approaches 3, x plus 3 over x plus 5. So substitute x with 3, we are going to get 3 plus 3, which is 6, over 3 plus 5, which is 8. So 6 over 8 is simply 3 over 4. Okay, so this is the answer for the limit. Okay, so now let us check the third one. So we already say this is continuous, so the first condition as well as the second condition should be equal. Therefore, c must be equal to 3 over 4. Okay, so I do get the value of 1a, c is equal to 3 over 4. So let us proceed to b. As usual, let us make a group for this, and let us go to b. Okay, so number 1b. The function f is defined by, so ax squared minus 6 for x less 10 or equal to negative 5 over 4, bx plus 4 for x in between negative 5 over 4 as well as 7. And then we have 25 if x is greater than or equal to 7. Determine the values of a and b if f is continuous everywhere. Okay, so that means since f is continuous at x equal to negative 5 over 4, so I know for sure if I am calculating the limit for x approaches negative 5 over 4 on the left hand side, this one should be equal to the limit as x approaches negative 5 over 4 on the right hand side. Okay, so what is the function on the left? So the function is ax squared minus 6. The function on the right hand side, so that is bx plus with 4. So do make sure you are using the correct one. And then let us substitute x with negative 5 over 4. So this is a negative 5 over 4 square minus 6 equal to b multiply with negative 5 over 4 plus with 4. Okay, so over here I'm going to have 25 over 16a minus 6 equal to negative 5b over 4 plus with 4. Okay, so let me bring this negative 6 to the right hand side. So we got 25 over 16a, and this is negative 5b over 4. So 4 plus 6, so this is plus 10. Okay, so I'm going to multiply everything with 16. Okay, so this is 25a, and this is equal to 5 times 4, negative 20b. 10 times with 16, so this is 160. So that is the first equation. Okay, so now let us calculate the second one. So I'm going to calculate the limit as x approaches 7 on the left hand side, as well as the limit for x approaches 7 on the right hand side. So they are continuous, so this limit should be equal. So on the left hand side of 7, the function is bx plus with 4. On the right hand side of 7, the function is 25. Okay, so substitute x with 7, so we are going to get 7b plus 4, so this is equal to 25. So 7b is equal to 25 minus 4, which is 21. Therefore, b must be equal to 21 over 7. So b is 21 over 7, which is 3. So b is equal to 3, so that means I need to calculate the value of a now. So 25a is equal to negative 20 times 3 plus with 160. So negative 60 plus with 160, so this is 100. So 25a is equal to 100. So that means a must be equal to 100 over 25, which is 4. So that is the value of a and b. Okay, so I think I'm done with question number 1. So let us proceed to question number 2. Okay, so what is question number 2a? Find the derivative of fx equal to 1 over x plus 1 by using the first principle. Okay, so fx is equal to 1 over x plus 1, so we want to find its derivative. So f prime of x, so this is the limit as h approaches 0, fx plus h minus fx over h. Okay, so this is the limit for h approaches 0, fx plus h. That means every time you see your x, you should replace them with x plus h. So 1 over x plus h plus 1 minus 1 over x plus 1 over h. So now let us have a common denominator. So this is the limit of h approaches 0, x plus 1 minus x plus h plus 1 over h, x plus h plus 1, x plus 1. And then of course x will be cancelled out with x, 1 will be cancelled out with 1, so we are going to get negative h. So this is the limit of h approaches 0, negative h over h, x plus h plus 1, x plus 1, and then now we cancel out the h and the h, so we got negative 1 over here. So this is the limit of h approaches 0, negative 1 over x plus h plus 1, x plus 1. And then you're going to replace the h with 0, so this is negative 1 over x plus 1 times with x plus 1. So we do see x plus 1 twice, so we can actually combine them together to be negative 1 over x plus 1 square. Okay, so that is question number 2a. Oh, By the way, kalau rasa macam dengar bunyi macam bising sikit tu kan, tu sebab dekat luar dia macam nak hujan. So dia bising sikit. Punya angin lah kiranya, kuat sikit. Kalau tak dengar muncul baru. Fokus. Okay, so let me answer question number 2b. 1 now. Okay, so find the derivative of the following function. So we have fx equal to cotangent of the square root of 4x squared plus 1. Okay, so now let us differentiate this. Okay, so f prime of x. So differentiating cotangent first. So if we do differentiate cotangent, we are going to get negative cosecant square and then whatever we have behind. So this is negative cosecant square root of 4x squared plus 1. And of course after that we need to differentiate 4x squared plus 1 to the power of half. So kalau ikut sebenarnya dia ada set kan, tapi saya tukar dia dalam kuasa half lah sebab saya rasa senang sikit saya nak kira. Okay, so now the in front part we simply copy down. So this is negative cosecant square, the square root of 4x squared plus 1. So now I'm gonna differentiate this function. So bring down the power, so half, copy down the function 4x squared plus 1. But instead of half, I'm gonna deduct 1 to the power, so this is negative half. And then we're gonna differentiate 4x squared plus 1, so we are going to get 8x. Okay, so when you do simplify them, you are going to get 4x over the square root of 4x squared plus 1. So ini yang bahagian belakang ni lah. Saya simplify 8 and 2, so this is 4x. And then the square root of 4x squared plus 1 to the power of half. Okay, so now this one we have negative, so saya letak negative kat depan. And then we have cosecant square, the square root of 4x squared plus 1. Okay, so that is actually the simplest form. So jangan pandai-pandai potong-potong yang angle dengan yang bawah denominator ni. That's it. Done with number 2b1. Okay, so now let us proceed with 2b2. Okay, perhaps use another colour. I think I like green. Okay, green then. Right, so number 2b2. Okay, so what do we have? We have fx equal to e to the power of 2x ln of 3x plus 4. So obviously in order to differentiate this, we need to use some product rule. So one of them will become a u, another one will become a v. So we're going to use u v prime plus v u prime. Okay, so f prime of x. Okay, so u first, e to the power of 2x, differentiating a ln. So you need to remember the formula for the ln. So d over dx ln of something. So this is 1 over something, and then we're going to differentiate that something. And by the way, let me write down the formula for the exponent as well. So e of something. So copy down e of something, and then we're going to differentiate that something. Okay, so this one. Continue, e to the power of 2x, differentiating ln. So we're going to multiply with 1 over 3x plus 4. And then differentiating 3x plus 4, we are going to get 3 plus ln of 3x plus 4 multiply with I don't think I have the space, so kejap kita bawa ni ke kiri sikit so that I can have an ample space. I think this one is not okay. Right, so now this is V, U prime now, differentiating exponent. So firstly copy down the exponent, differentiating the power, so we are going to get 2. Okay, so simplify them a little bit. So we got 3e2x over 3x plus 4 plus 2e2x ln of 3x plus 4. Okay, so of course you do see something in common because we have e to the power of 2x. Sepatutnya dah tekan highlight, dia tak keluar highlight lah. Then how? Dah highlight belum? Okay, dah. Okay, so we have e to the power of 2x. So that means I can actually factorize them out. So this is, oops. So e to the power of 2x, and then I have 3 over 3x plus 4 plus 2 ln 3x plus 4. Okay, so that's it for question number 2b2. So we're gonna do the last question for part A. Kenapa saya rasa macam tulisan dia small sangat sampai saya pun tak boleh baca. Saya rasa sebab saya zoom kot, so dia jadi small sikit. Okay, so now I can read them. Okay, so question number 3. The side of a cube of length x cm is increasing at the rate of 2.5 centimeter per second. How fast is the volume of the cube increasing when the side is 8 centimeter long? Okay, so we have a cube. So nak lukis cube ke? Boleh je kalau nak lukis. Oh, lawa cube I. Okay, so now the side. So the side is x over here. Okay, so the side is increasing. Okay, so I have dx then. So I have dx over dt. So this is equal to 2.5 centimeter per second. So it's supposed to be positive because we have an increasing. How fast is the volume increasing? So we want to know what is dv over dt when the x is equal to 8. Okay, so basically if I did start from dv over dt, so this is dv over something over dt. So the only thing that I have over here is dx. So this one should be dx over dt, and this one should be dv over dx. And dx over dt is actually equal to 2.5. Okay, so now let us obtain what is dv over dx. So mula-mula kena ada volume dulu lah. Okay, so what is the formula for a volume? So this is a cube. Cube, that means we have the same length, the same macam ni, panjang, lebar, tinggi. So we got a similar thing. So this is also x, that is also x. So x times x times x. So this is actually x cube. So that means dv over dx is actually 3x square. So dv over dx, 3x square multiply with 2.5. And then I'm going to substitute. X is actually equal to 8. So 8 square. 2.5 is actually 5 over 2. So let us simplify and get the value. Okay, so basically when we calculate this, so the answer for this is actually equal to 480. So the unit is, so volume, so that means this is centimeter cube per second. Okay, so this is question 3 part A. So now let us do question part B. Okay, so saya besarkan sikit lah soalan ni, nanti kita tak tak boleh baca. Baik saya turunkan je soalan ni. Buat penat je, kecil besar. Okay, so question number 1. Given two complex numbers, Z1 is 5 plus 3i, Z2 is 2 minus I. And then number 1a, state Z1 bar and Z2 bar. So Z1 bar, so the conjugate for Z1 is 5 minus 3i. And then Z2 bar, so I'm gonna conjugate this one as well. So this is 2 plus I. So 5 minus 3i, 2 plus I. Okay, B. That's it, 1 mark only. Determine the value of K if 1 over Z1 is equal to K Z1 bar. Okay, so 1 over Z1, so 1 over 5 plus 3i. So this is equal to K multiply with 5 minus 3i. Okay, so I'm going to make K as the subject. So K is equal to 1 over 5 plus 3i multiply with 5 minus 3i. Okay, so we're going to expand that. So what do we have is 1 over, so 5 times 5, 25 minus 9i square. So I square is actually equal to negative 1. So we got negative 9, negative 1, so plus 9. 25 plus 9 is 34, so 1 over 34. And this is actually the value of K. Okay, so that is for B. So I have done B as well. So let us go to C. Okay, so number 1C. Find Z1, Z2. Okay, so Z1 times with Z2. So this is equal to 5 plus 3i times with 2 minus I. So I'm going to expand this. So this is 10 minus 5i plus 6i minus 3i square. And I square is equal to negative 1. So negative 1 times negative 3 is plus 3 plus 10. So that is actually equal to 13. Negative 5, positive 6. So this is positive I. So this is Z1 multiply with Z2. So show that Z1 bar, Z2 bar is equal to Z1, Z2 bar. Okay, so firstly, let me calculate Z1, Z2 bar first. So the conjugate of 13 plus I, so this is 13 minus I. And then let us calculate Z1 bar multiply with Z2 bar. So I already have the value previously, so 5 minus 3i, 2 plus I. So expanding them, so 10 plus 5i minus 6i minus 3i square. And I square is actually equal to negative 1 times with negative 3, so positive 3 plus 10, so 13. 5 minus 6, so this is negative I. And then as you can see, Z1, Z2 bar, this is 13 minus I. Z1 bar times with Z2 bar is also equal to 13 minus I. Therefore, Z1, Z2 bar is actually equal to Z1 bar, Z2 bar. Okay, so that is for C. So done with number 1C. So let us proceed with the next one. Sekejap Dia hang jap, tak boleh nak kecilkan. Tak apalah, kalau tak boleh kecilkan, kita gerakkan je. Boleh dah. Okay. Okay, so let us do question number 2 then. So 2a. Solve log x minus 4 plus 2 log 3 equal to 1 plus log x over 2. Okay, so firstly, whenever you see something with a log, do check the base first. Okay, so base kat sini 10, base kat sini 10, base kat sini 10. So I do have a similar base for almost everything, except that untuk satu ni dia bukan log. So if I want to, I can actually change this one. So 1 can be changed to log 10 10, because log 10 10 is equal to 1. Okay, so now what I will do is I'm gonna make a log plus a log. So I'm gonna bring this one up first. So this is log 10 times with x minus 4 plus with log 10 3 square equal to log 10 10 plus log 10 x over 2. Okay, so now I'm going to combine them because we have a plus between the two log. So this is actually equal to log of x minus 4 multiply with 3 square. Of course, this is log 10. So this is also equal to log 10 10 times with x over 2. Okay, so since for both of them I got a similar log, so I have log to the base of 10, I have log to the base of 10, and both of them are single. So that means I can straight away compare whatever I have at the back. So when I compare them, I'm going to get 9 multiply with x minus 4, and this is equal to 10 multiply with x over 2. Nampak ke pakai ni? Boleh lah kot. Okay, so this is 9x minus 9 times 4, 36. So this is equal to 5x. So I'm going to bring x to the left hand side, 36 to the right hand side. So this is 4x equal to 36. So x will be equal to 9. Okay, so we are done with number 2a. So let us proceed with 2b. Okay, so number 2b. Okay, so find the solution set. So solution set of the inequality. So modulus of x minus 3 over x plus 1 less than 2. So we're going to open the modulus sign first. So this is 0. So we got positive 2, negative 2, less than. So less than is somewhere in between. So we will have x minus 3 over x plus 1 greater than negative 2, because we are going to the right hand side from negative 2, and from 2 we are going to the left hand side. So at the same time, I want my answer to be x less than x minus 3 over x plus 1 to be less than 2. So we are using n because over here we only have one interval, so dia kena satisfy dua-dua lah, kiri dengan kanan kita. Okay, so now x minus 3 over x plus 1 greater than negative 2. I'm going to bring it to the left hand side. I'm going to bring negative 2 to the left. So we got x minus 3 over x plus 1 plus 2 to be greater than 0. So this is x minus 3 plus with 2x plus with 2 over x plus 1 greater than 0. So x plus 2x is 3x. Negative 3, positive 2, so negative 1 over x plus 1 greater than 0. Okay, so now we're going to do the real number line. So assume 3x minus 1 greater than 0. So x greater than 1 over 3. Another one is x plus 1 greater than 0. X is greater than negative 1. Okay, so now on the left hand side we got negative 1 So over here, this is 1 over 3. So negative 1 going to the right hand side. 1 over 3 also going to the right hand side. And then of course, those with the line, I'm going to write down a positive because we are assuming them to be positive. So positive, positive, positive. Those without line, negative. So this is positive, negative, positive. So to know which one is our answer, so go back. So before you assume, go back and check what is the sign. So we want to find something that is greater than 0. So this is for positive. So my answer will be positive. So the interval will be negative infinity until negative 1, and then 1 over 3 up until infinity. Okay, so that is the answer on the left hand side. Let us solve the right hand side now. Okay, so now let us solve the right hand side. I'm going to bring 2 to the left. So we have x minus 3 over x plus 1 minus 2 less than 0. Macam gelap lah warna dia, tapi tak apalah. So x minus 3 minus 2x minus 2 over x plus 1 less than 0. So x minus 2x, negative x, negative 3, negative 2, negative 5 over x plus 1 less than 0. So now we're going to assume negative x, negative 5 greater than 0. So for the assuming part, I always assume them to be greater than 0. Okay, so this is negative x greater than 5. So x will be less than negative 5. Okay, so the other one. So we got x plus 1 greater than 0. So x will be greater than negative 1. Okay, so draw the number line. So we got negative 5, negative 1. Okay, so negative 5 going to the left hand side, negative 1 going to the right hand side. And since we are assuming them to be greater than 0, so I should always write down positive on top of the line. Those without the line, it will become negative then. So negative, positive, negative. Okay, so basically before I assume, so the last fraction, I want them to be less than 0. So that means I want to get some negative answer. So the negative answer for this is on the left hand side, right hand side. Therefore, this is from negative infinity until negative 5 and negative 1 up until infinity. Excuse me. Okay, so once we have the answer, both on the left hand side as well as the right hand side, so we should refer back to the word that we write down when we open our modular sign. Okay, so when we open the modular sign, we are using the word and. And simply means that once I know what is the answer on the left hand side and what is the answer on the right hand side, I'm gonna find out what is the intersection between these two answers. If let's say we have an or, it simply means that we're gonna unite our answer on the left and on the right. So I'm using and, so mari kita gabungkan dia, cari kawasan intersection. Okay, so I have negative 5 and then negative 1 as well as 1 over 3. So on the left hand side, I have negative 1 going to the left hand side, 1 over 3 going to the right hand side. The other one, I have negative 5 to the left, negative 1 to the right. Right, so we simply want to find what is the solution. So we want to get what is the intersection. So the intersection is somewhere here as well as here. Therefore, the solution set for them is x such that x less than negative 5 or x would be greater than 1 over 3. So this is the solution set. Okay. So we are done with question number 2. Let us proceed with question number 3. Okay, jom kita kecilkan sikit. Okay, so let us proceed with question number 3. given that hx is e to the power of negative 2x for domain negative infinity to infinity, find h inverse, take the domain and the range. Okay, so number 3a, so we want to find h inverse, so we need to know something. So h composite with h inverse is actually equal to x. So I'm gonna replace h inverse inside there. So we got e to the power of negative 2 h inverse of x equal to x. So I'm gonna apply ln on both sides. So negative 2 h inverse is equal to ln of x. So h inverse of x is simply equal to negative 1 over 2 ln of x. Okay, so now what is the domain and the range? Okay, so domain, range. Okay, so basically the domain, so we got a ln over here. So for a ln, we need to be very careful because the number behind the ln should always be greater than 0. So in this case, x will be greater than 0. So the domain will be 0 up until infinity. Meanwhile, for the range, kita pakai f pula. Sekejap So this is h inverse. Okay, so range is equal to the domain of h. So the domain of h is negative infinity up until infinity. Okay, done. So now let us proceed to B. Okay, B. Number 3B. Tebalnya lah. Okay, number 3B. Tak nampak apa-apa. Sketch the graph for hx and h inverse. Okay, so x and then y. Okay, so we got hx equal to e to the power of negative 2x. So yang ini siapa yang tutur saya tahu kot. Saya selalu pakai Ika kan. So we're gonna calculate what is the intercept first and then the quadrant as well as the asymptote. Okay, so the intercept when x is equal to 0, I have h of 0 equal to e to the power of 0, which is 1. So this is equal to 1. Okay, so quadrant. So I have negative value of x. So for the quadrant, it will be negative. In front of the exponent, I have positive. So the value of x will be negative. The value of y will be positive. So above here somewhere. So kalau tak nampak, jap saya pakai colour lain. Up here, this is the negative of x, positive of y. And then the asymptote. Asymptote, if you look at the e, so the e is actually plus with 0. So the asymptote is y equal to 0. So the asymptote is over here, y equal to 0. Dan ngam-ngam sama dengan x lah. Tapi saya bagi atas sikit supaya nampak. Awak lah nampak. Nanti kalau lukis, kena lukis ngam-ngam lah. Okay, so now I'm gonna connect everything. So I need to make sure I start from here. I need to meet 1 and then I need to approach my asymptote. So okay, so perhaps something that look like this. So this is h of x and you need to sketch the h inverse. So you need one thing, which is the line y equal to x. So this is y equal to x. Okay, so basically y equal to x, it simply means that we're going to have the opposite of whatever we have for hx. So for example, if let's say for hx, I'm going to have the intercept at y equal to 0. So that means for this one, I'm going to have the intercept at x equal to 1. So y equal to 0, x equal to 1. And then over here, I'm going to x with a negative, y with a positive. So that means over here it will be x that is positive, y that is negative. So over here then down. And then the asymptote is basically at x equal to 0. So x equal to 0 is this line over here. So you need to make sure you start from here, meeting 1, and then kena rapat dengan asymptote. So sekejap, dia kena penuh bersabar sekejap nak lukis ni. Warna merah lah. Okay, so rapat dengan asymptote, sentuh 1, lepas tu okay, jauh, almost lah, kecuali tangan macam Parkinson sikit. I'm sure you can draw better than me. Oh, by the way, titik tu just nak make sure kita berada di kuadran yang betul lah. Okay, done with that. So that is question number 3B. So let us proceed with the next question. Question number 4. Okay, so given that fx is ln 2x plus 3, gx is ex minus 3 over 2, show that fx is 1 to 1. Right, so number 4a. Right, so we need to start with fx1 equal to fx2. So this is ln of 2x1 plus 3 equal to ln 2x2 plus 3. Since we are having a ln and they are single, so we can actually compare the number behind. So 2x1 plus 3 is equal to 2x2 plus 3. Deduct 3 on both sides, so 2x1 is equal to 2x2. Therefore, x1 is equal to x2. Okay, so since fx1 equal to fx2 implies that x1 equal to x2, then fx is 1 to 1 function. Okay, so do make sure kena ada conclusion jangan kira-kira je lepas tu tak ada conclusion. You need to write down your conclusion. Okay, so the next one, find f composite with g and g composite with f, hence state the conclusion about the result. So kalau kita baca macam tu pun dia macam ada sesuatu je. Bila dia kata hence tu, we must use this one. So f composite with g, I'm guessing that it can be inverse of each other. So saya rasa saya macam dapat x kot, sebab gaya dia tulis tu macam boleh dapat x. Okay, so this is f composite with g, so I'm gonna replace the x in f with g. So this is ln of 2 times with g, so ex minus 3 over 2, and then plus with 3. Okay, so we're gonna cancel out the 2 and the 2, so we got a ln of ex minus 3 plus 3. So this is actually ln of ex. So this one can be simplified to get an x. See, I get them right. Okay, so now g composite with f. Kita cukup space je. Okay, tak apa, sini lah. Right, so g composite with f of x. Okay, so this one, this is g f x. Okay, so what is g, gx, and fx? Okay, so gx is equal to ex minus 3 over 2, and then ln is ln 2x plus 3. Okay, we need to make sure we get them right. Okay, so g composite with f, so I have to replace the f inside the g. Okay, so this is e to the power of ln 2x plus 3 minus 3 over 2. Okay, so we got e to the power of ln. I can bring the power down, so 2x plus 3 minus 3 over 2. So ini saya bawa turun je power, sebab kita ada e to the power of ln. Okay, so we got 3 minus 3 cancel out, 2x over 2, so this is actually equal to x. Therefore, f composite with gx is equal to g composite with fx, and this is actually equal to x. So fx and gx are the inverse of each other. Ataupun kalau rasa macam payah nak faham je kan soalan tu kan, betul sini gx is equal to f inverse, fx is equal to g inverse. So inilah maksud kita, dia adalah inverse of each other. Okay, so I'm done with question number 4. So let us proceed with number 5, number 6, and then number 7. Okay, so let us answer question number 5 now. Given that fx is equal to x cubed minus 64 over x minus 4, so this is for x not equal to 4, and then 40 when x is equal to 4. So firstly, find out the limit for x approaches 4 for fx. Okay, so number 5, A1. Okay, so we need to calculate the limit for x approaches 4 for fx. So kalau limit maksudnya dia tidak menghampiri, so we cannot choose x equal to 5. So we must choose x not equal to 4, 5 but x equal to 4. So we cannot choose x equal to 4 because we are simply approaching them. So we're going to choose x not equal to 4. So this is equal to the limit of x approaches 4 of x cubed minus 64 over x minus 4. So if we do try to substitute with x equal to 4, we are going to end up with 0 over 0. So you know for sure that for this one you need to factorize them. Sebab conjugate tak boleh kan, so kena factorize. Okay, so how to factorize them? Alright, so basically for me, I say there are two methods to factorize them. So you can either do a long division. So do a long division to get your quotient so that you can write them down nicely in this factor. Or you can also remember the formula if we have a cubed minus with b cubed. So the formula, if we have a cubed minus b cubed, so this is a minus b, and then a square plus ab minus plus with b square. So a minus b, a square plus ab plus b square. So this is actually the formula. So up to you. Do you want to remember the formula or do you want to do a long division? Okay, so since I don't normally remember the formula myself, so let us do a long division then. Okay, so x cubed plus with 0x squared plus with 0x minus with 64, and then we're going to divide them with x minus 4. So x times with x squared, we are going to get x cubed minus with 4x squared. So minus, so we are going to get 4x squared. So this is plus 4x. So this is 4x squared minus 16x. So you minus them, you are going to get 16x minus 64. So this is positive 16. Okay, so what do we have over here? So this is the limit for x approaches 4. So x cubed minus 64, I already factorized them to become x minus 4 and x squared plus 4x plus 16 over x minus 4. So cancel out x minus 4 and x minus 4. So this is the limit for x approaches 4, x squared plus 4x plus with 16. So simply substitute x with a 4. So we got 4 square plus 4 times 4 plus with 16. So kita ada 16 kali 3, 48. So this is the answer for the limit of x approaches 4. Okay, so I have answer part 1. Is f continuous at x equal to 4? Give your reason. Okay, so firstly, in order to check the continuity, we have 3 conditions. So let us check all of them. So this is 2, A2. Okay, so the first condition, we should check what is the value when x is equal to 4. Are they defined or not? So when x is equal to 4, I know that the value is equal to 40. The second condition, I should check the limit of x approaches 4 for fx, and I already calculated them previously, so this value is equal to 48. So now the third condition, as you can see, f of 4 and the limit of x approaches 4 for fx, so one of them is 4, another one is 48, so they are not equal. Therefore fx is not continuous at x equal to 4. So not continuous lah, sebab dia doesn't satisfy the third condition. Okay, so now basically if you do try to substitute with x equal to 2, we are going to end up with 0 over 0. So if we have 0 over 0, that definitely mean that we need to factorize them, because I didn't see anything with a set, definitely a factorize. But since we have an absolute value, we need to refer to the definition of an absolute value as well. So the absolute value of x, it can become positive and it can be negative as well. So x minus 2, this is for x greater than or equal to 2. The negative of x minus 2, this is for x less than 2. Therefore, as we are approaching 2, I need to check, am I approaching 2 from the right hand side or am I approaching 2 from the left hand side? So we should separate these into 2 cases. So the first one, I'm approaching 2 on the right hand side. The second one, I'm approaching 2 on the left hand side. So as I approach 2 on the right hand side, so it will become x squared plus 4x minus 12 over the positive of x minus 2, and then of course I'm going to factorize my numerator. So this is the limit for x approaches 2 on the right hand side of x minus 2, x plus 6 over x minus 2. Cancel out x minus 2 and x minus 2. So this is actually the limit of x approaches 2 on the right hand side of x plus 6. So substitute x with 2, you are going to get this equal to 8. Okay, so now the second one, the limit for x approaches 2 on the left hand side. So the function will be x squared plus 4x minus 12 over the negative of x minus 2. So kita pakai negative lah sebab this is for x less than 2. Okay, so now I'm gonna factorize my numerator. So this is the limit for x approaches 2 on the left. So it will become x minus 2, x plus 6 over the negative of x minus 2. Cancel out x minus 2 and x minus 2. Therefore, this is the limit of x approaches 2 on the left for negative of x plus 6. So substitute x with 2, we are going to get negative 8. So one of them is positive 8, another one is negative 8. So we know for sure that the limit for x approaching 2 does not exist. Okay, so the limit for x approaches 2 on the right hand side for fx does not equal to the limit for x approaches 2 on the left hand side for fx. Therefore, the limit for x approaches 2 for fx does not exist. Okay, so we can go to the next question now. Okay, so find the limit of x approaching 1 for 1 minus set x over 1 minus x. So 5b2. So the limit for x approaching 1 for 1 minus set x over 1 minus x. So if you do try to substitute x with 1, you are going to get 1 minus 1 over 1 minus 1, which is again 0 over 0. So I do see something with a set, so I'm gonna multiply with the conjugate. Okay, so this is basically the limit as x approaching 1 for 1 minus zx over 1 minus x times with 1 plus zx over 1 plus zx. Okay, so this is the limit as x approaching 1 zx, so this is negative x over 1 minus x 1 plus zx. So you cancel those two out, so we got a limit for x approaching 1 over 1 plus zx. So substitute x with 1, we are going to get 1 over 2 as our answer. So finally I'm done with question number 5. Let us proceed with question number 6. Okay, so let us answer question number 6 now. Okay, so parametric equation of the curve is given by x equal to 4t over t square minus 1, y equal to 3t square plus 1 over t square minus 1. Find out dy over dx and d2y over dx square. Okay, so number 6a1. Okay, so x is equal to 4t over t square minus 1. So in order to differentiate this, I need to use a quotient rule. So vu prime minus uv prime over v square then. So dx over dt. Okay, so v first. V is t square minus 1. Differentiating for t, so we are going to get 4 minus 4t. Differentiating t square minus 1, we are going to get 2t over t square minus 1 square. Okay, so now let us simplify our numerator. So we got t square times 4. So this is 4t square minus 4 minus 8t square over t square minus 1 square. So what do you have is negative 4 t square negative 4 over t square minus 1 square. Right, so factorizing negative 4, we are going to get t square plus 1 over t square minus 1 square. So that is dx over dt. So now the y. Okay, so y is equal to 3t square plus 1 over t square minus 1. Again, we are going to use a quotient rule for them, and the formula is similar to this one. Okay, so now let us focus on the formula. So dy over dt is equal to... Okay, so now v first, so we got t square minus 1. Differentiating 3t square plus 1, so we are going to get 6t minus 3t square plus 1. Differentiating t square minus 1, we are going to get 2t over t square minus 1 square. Okay, so now simplify your numerator. So t square times with 6t, so 6t cube minus 6t. 3t square times with 2t, so it will become negative 6t cube negative 2t over t square minus 1 square. So 6t cube cancel out, negative 6, negative 2, negative 8t over t square minus 1 square. Okay, so now let us calculate what is our dy over dx. Okay, so dy over dx is actually equal to dy over dt times with dt over dx. So we're going to use some chain rule for them. So dy over dt, so yang inilah dy over dt. So this is 8 negative 8t over t square minus 1 square. This is dx over dt, so I want dt over dx, so I'm going to flip them. So this is t square minus 1 square over negative 4 t square plus 1. Okay, so cancel out. So what do you have left is negative 8t over negative 4 t square plus 1. So positive 8, 4, 2. So what do we have left is 2t. So what do we have is 2t over t square plus 1. Okay, So done with this. That is part A, part 1 actually. Kenapa pula dah budak tu jerit petang-petang ni. Okay, so now let us calculate the second derivative, d2y over dx square. So this is d over dt of dy over dx multiply with dt over dx. So that means we're gonna differentiate 2t over t square plus 1, and then we're gonna times with t square minus 1 square over negative 4 t square plus 1. Okay, so let us differentiate using the quotient rule. So v first, t square plus 1, differentiating 2t, we are going to get 2 minus 2t. Differentiating t square plus 1, we are going to get another 2t over t square plus 1 square. Multiply with t square minus 1 square over negative 4 t square plus 1. Okay, so I'm going to simplify my numerator. So that is 2t square plus 2 minus 4t square over, so this is t square plus 1 square multiply with t square minus 1 square over negative 4 t square plus 1. Okay, so let us simplify our numerator. So this is negative 2t square plus 2 over t square plus 1 square times with t square minus 1 square over negative 4 t square plus 1. Okay, so this one will become negative 2t square plus 2 multiply with t square minus 1 square over negative 4 t square plus 1 cube. So it said earlier that t is equal to 2. So that means d2y over dx square is equal to, right, so we got negative 2 times with 4 plus 2 multiply with 2 square, so 4 minus 1 square over negative 4 plus 1 cube. Okay, so apa yang kita ada kat sini, negatif 8 tambah 2, so negatif 6. So 3 kuasa 2, 9, bahagikan dengan negatif 4, 5 kuasa 3, 5 kuasa 3, 125. Okay, so this one will become a plus. So this is 2, this is 3. 3 times with 9, so this is equal to 27 over 125 times 2, so this is 250. So that is question number 6A. Okay, so let us proceed with the next one. Okay, so it said over here that y is equal to 5 minus x e to the power of negative 2x. Find dy over dx. Okay, so number 6b. So y is equal to 5 minus x e to the power of negative 2x. Okay, so what is dy over dx? So obviously for this one we have to use some product rule for them. This is a product between two things. So 5 minus x, differentiating the exponent, so copy down the exponent, differentiate the power, so we times with negative 2 plus e to the power of negative 2x. Differentiating 5 minus x, we get negative 1. So this is e to the power of negative 2x. And then we got negative 2 times with 5 minus x minus 1. So this is e to the power of negative 2x. Negative 10 positive 2x minus 1. So this is e to the power of negative 2x. 2x minus 11. Done with question number 6b. So now let us proceed with question number 7. Okay, so let us read the question. Water is leaking. Leaking maksudnya nilai dia nanti akan jadi negatif lah, volume. radius of 1.5, height of 2 meters. So we got a cone, so I'm gonna draw a cone over there, and then the rate is 0.25 cubic meter per minute. So this is actually the volume. The tank was initially full. If the height of water is 1 meter, then find the rate of change of the water level and the radius of the water surface. Okay, so let us draw the cone first. Okay, so radius 1.5, the height is 2. Okay, so now what do we know? We got a rate over here. So this is dv over dt equal to negative 0.25. Okay, so now what do they want in A? Find the rate of change of the water level. So we want to know dH over dt. Okay, so what is dH over dt? So kalau kata kita buat chain rule for that, so dH over dt is equal to dH over something over dt. So the only thing that I have with dt is dv, so this is definitely dv, and this is also dv. With dv over dt is equal to negative 0.25. So that means I need to know what is dH over dv. Okay, so what is the formula for the volume of a cone? So this is 1 over 3 pi r square h. So I need to make sure I have dv over dh. So I need to do something with the r. So r tu kita kena ubah dalam sebutan h. Okay, so let's see how can I change this. Right, so basically if this is my water, so this is the radius and this is actually the height, so that is the h. So by trigonometric ratio, okay, so if this is my angle, then that means the opposite of this is 1.5 over 2, and this is actually r over h. Okay, so 1.5 is 3 over 2 over 2, so this is 3 over 4 equal to r over h. So r is actually equal to 3 over 4 h. So you can replace the r over here with 3 over 4 h. Therefore, V is equal to 1 over 3 pi 3 over 4 h square h. So we got 1 over 3 pi 3 over 4 is 9 over 16, and then h cube. So I simplify them. I'm going to get 3 pi over 16 h cube. So this is my V. So let me find out what is dv over dh. So bring down the power, so we got 9 pi over 16 h square. Okay, so I already have dv over dh. So for my question, I need dh over dv, so I'm going to flip them. So this is 16 over 9 pi h square times with negative 0.25. Okay, so what is the value of h? Okay, so h is equal to 1 meter. So this is 16 over 9 pi. H is equal to 1. Negative 0.25, this is actually negative 1 over 4. So I'm going to simplify them. Therefore, it will be negative 4 over 9 pi meter per minute. Okay, so this is dH over dt. So now let us calculate the P, the radius of the water surface. I want to get the R over dt. So the R over dt is the R over something over dt. Okay, so I already have dH over dt actually, so I can use dH and dH over here. dH over dt is equal to negative 4 over 9 pi. What about the R over dH? Okay, so previously I have R is equal to 3 over 4 h. So that means the R over dH is actually equal to 3 over 4. So dr over dt is equal to 3 over 4 times with negative 4 over 9 pi. So when you times and simplify them, it should be equal to negative 1 over 3 pi meter per minute. So done with question number 7b. So I'm done with the third set. Okay, so I'll see you guys in the fourth set tomorrow, I guess. So have a nice day. Bye. See you tomorrow.